Here we'll take a look at an application of conditional probability, and our problem is a group of 150 teenagers took a driving test. Before the test, some took a driver's education class, the rest did not, and we've got our results in a two-way frequency table. All right, so two-way again means just considering two things, whether or not they took a class and whether or not they failed or passed. So before I go too much further here, let me do some totaling. So of these 150 teenagers, it looks like 87 failed their driving test and 63 passed their driving test. If you add those up, you'll get your 150 teenagers. But they also kept track of whether they took driver's education class. It looks like 90 did and 60 didn't. And again, that's your 150 teenagers. All right, so we'll start with picking a teenager at random from this group, find the probability that they passed the test. So if there's no condition, there's no given that statement, we are always using a denominator of the number of items in our entire sample space, so S. So if there's no condition, you're looking at all 150 teenagers. So I'm just going to write my denominator here. So I'm looking at my entire sample space, 150, and of all those teenagers, the number of them that passed the test, there were 63. Okay, and in this case, I am going to write that in decimal as well. That'll be 0.42 or 42%. So there's a 42% chance that if you pick one of these random teenagers at random, they will have passed their test. So now the application of conditional probability. It says, find the probability the teen passed the test, given that she took a driver's ed class. So in other words, if we only consider people that took a driver's ed class, what percent of them passed their test? So the probability of getting somebody who passed, given that, we're only going to consider those that took the class. So this, after the vertical line, called a pipe, but after that vertical line, this is your condition. And that tells you who you're allowed to consider with the probability. So just for emphasis, I'm going to actually write out that row. So the condition is I'm only allowed to look at that row of people that took the class. So these are my took the class people. So I had 21 that failed, 39 that passed, and that total was out of 60. Okay. So I'm going to just go to this answer without a formula. Let's go through the concept. I'm only allowed to look at people that took the class, and there were 60 of them. So the condition tells you who you're going to consider. So what will your denominator be? All right, so we're only looking at the 60 people that took the class. So if we only look at them, the condition. Now it says, what is the probability they passed, given they're among this group? So the people that passed, that was our 39. So 39 out of the 60 passed their test. And they had also been people that took driver's ed. Okay, so I rewrote this across just to really make sure to emphasize that the whole table is obviously still here, but the condition restricts who you're allowed to consider. You have to ignore everybody else. If you're not part of the took the class, then you're not part of this problem. And then I'm going to go ahead and write that in decimal. So if you divide that, you'll get 0.6 or 60%. So the idea here is that in general, 42% passed. But if you consider people that took driver's ed, that bumps up to a 60% pass rate. So it's looking like taking driver's ed was helpful because I'm seeing a pretty big jump in the percentage who passed. So that's this last part. It says, is there evidence that a teen who takes the class is more likely to pass the test than a randomly chosen teenager from the group? So this is a bit subjective, but I think this is a big enough jump for me to say taking the class appears to be helpful. If it had gone up instead of to 60%, if this had been maybe 43% or 44, I wouldn't think it's a dramatic difference. But when it gets to be, I don't know, between 10 and 20%, I would definitely go with yes. So a little subjective, use your judgment, but I'm going to say yes. I do think taking the class helped you more likely pass the test because my answer in part B is higher than my answer in part A. Okay, so we'll end with just a round of conditional probability. And I'm just going to go to a bag of marbles, 6 of them. So I've got my sample space over here, 1, 2, 3, 4, 5, 6 marbles. And A, what is the probability that marble 2 is selected? So there's no condition, you're looking at your entire sample space, and of those 6 marbles, there is only one marble, number 2. So I am going to write a little notation. Writing just the answer is totally fine. I just like to have something in my notes. So the probability I pick marble 2, there's one marble 2 out of 6 marbles. And now we're just going to stay in fraction here. All right, in comparison for B, what is the probability that I get marble 2 given that, so given that, the vertical line, given that it's a gray marble. So you're only allowed to look at the gray marbles. So rather than writing the formula, I'm just going to, on the side here, let me put my gray marbles. So my gray marbles are 2, 3, 5, 6. So I have 4 gray. So my denominator, you're looking at the 4 gray. So the condition tells you the marbles to look at, 4 of them. And then looking only at those marbles, what is the probability I pick marble 2? So of course, there's still just one marble 2, but now it's out of the ones that are gray. So 1 out of 4. Okay. So you can write the formula or not, up to you. For this one, I'll go ahead and write the formula. What is the probability of even given it's a white marble? So it'd be the number of marbles that are even and white. So the numerator is always the intersection, the ones that satisfy both criteria, and your denominator is always the number that meet the condition. Okay. Or just conceptually, and again, I'm writing more than you would need to, the condition is I can only look at the white marbles. The white marbles are 1 and 4. So the number of white marbles, there's 2 white marbles. And of the white marbles, the chances of getting an even one, if you pick from the whites, one number there is even. So 1 is an even white number out of 2 white numbered marbles. All right. So add more English to it if you would like. I won't do this, of course, for everyone, but there's 2 white marbles. Right, so 2 white marbles and one marble is both white and even. So there's the English. And of course, that's the same as what's written here in symbols. Okay, so then we'll just wrap up here then. So for the next one, what is the probability of white given even? So the condition before was white, the condition now is even. So I'm only allowed to look at evens, 2, 4, 6. So I'm just going to go to the answer now. There's 3 even numbers. So if you only look at those 3 numbers, the probability of getting one that's white out of those 3, so out of 2, 4, 6, the only white one is the 4. So 1 is both white and even out of 3 even numbers. Okay, on the next one, I'll just go back to writing the formula. So whatever helps. So you can either say, I know I'm only going to look at the odds. So probability of gray given odd. You don't have to write this down. It's just kind of the thought process. I'm only allowed to look at the odds. So I'm a little bit squished here. So let me come over here. All right, so probability of gray given odd. You're going to look at the number of them that are gray and odd. So the number that meet both conditions, looking only at the odds. So I wrote the odds. There's 3 of them. And out of those 3 odds, the ones that are gray, 2, 3, 5, 6, 3 and 5 are gray. So there's 2 that satisfy both conditions of being gray and odd out of those 3 odd. All right, and then I'll end with, you don't have to write anything. If you've got the concept down, that is great. I'm just coming over here because I'm out of space. So if I want the probability of odd given gray, what I do is say the condition is gray. And I think there were 4 gray up there, 4 gray. There's 4 that are gray. And now I'm just writing gray because I don't want to scroll up and keep going up and down. I'm going to do it anyway. Gray, 2, 3, 5, 6. So gray, 2, 3, 5, 6. There's the gray. So if I pick one of them, the probability of an odd, picking just from the gray ones, the probability of odd, the odd numbers there are 3 and 5. So 2 out of those 4 gray ones are also odd. All right, so that wraps up conditional probability. You can just do an answer. You can do the formula to get the answer, do a little writing to show your criteria, your condition to consider. Whatever works for you is totally good. And that will end this section.